What the first section of this chapter is about is translations of graphs, and what you've done in the activity in the previous days has been to do some different transformations of shapes on a coordinate plane, and we're going to specifically talk about shapes and also graphs. So I just want to get the vocabulary out of the way first. A transformation is a change in the size or position of a figure or graph. And there are lots of different types of transformations that we're going to be talking about. Translations, reflections, stretches, shrinks, and rotations. And specifically today, we're going to be talking about translations. Also, another vocabulary word is the image, and that is the figure or graph of a function that is the result of a transformation. So after you have an original figure or a graph, maybe of a line or a parabola, then after it's been transformed, so maybe it's been slid over or down or up, or maybe it's been reflected or stretched or shrunk or whatever, then what's the result is called the image. And then the last vocabulary word is translation. That's specifically what we're talking about today. That's a type of transformation where it slides a figure or graph to a new position without changing its size or its orientation. Basically meaning that it's not being flipped around, it's not being rotated. All that's happening is it's just sliding left, right, up, or down. Go ahead and pause this for a minute if you need to copy down the definitions for those three vocabulary words. All right, we've just got one example for you. This really shouldn't be too difficult, especially after the activity that we've done over the last couple days. So the example is just of this pentagon, and it just says to sketch the image after a translation, right 4 units and down 3. Okay, so it says to define the coordinates of any point in the image using x, y as the coordinates of the point in the original figure. So basically I'm just going to take each point. I'm going to go, starting from this top one here, I'm going to go to the right 4 and down 3. Okay, this point I'm going to go 1, 2, 3, 4. Oops. So here, 1, 2, 3, 4, and down 1, 2, 3. Just do the best I can with what's given here. This one give over 1, 2, 3, 4, and down 1, 2, 3. This one over 1, 2, 3, 4, down 1, 2, 3. And the last point, 3, 4, 1, 2, 3. And then take a line and connect here to here. It's that easy. You can just do it for each point. And what you should be good at by now is writing a general rule. So define the coordinates of any point in the image using x, y. So if my original coordinate was x, y, I could look at a specific example if that might help. So let's look at this top point here. I'm going to highlight them for you so you can see which ones I'm talking about. So for example, this point would be 1, 4. And its image would be 5, 1. And what I know is that I'm looking at no change other than just sliding. So probably just going to be adding or subtracting numbers from x and y to get our new coordinates. So from 1 to 5, that tells me a change of 4, which makes sense because we're translating it right 4 units. So the x value tells us to add 4 units on because we're going to the right 4. So I'm going to have x plus 4. And then the y coordinate's going from 4 to 1, which means it's going down 3, subtracting 3, which makes sense because the y says it's going down 3 units. Okay, so y minus 3. And that's really all you've got to do. We've got our image drawn over here. I used 2 specific points on the original figure and the image to help me. And then I just wrote a general rule with any x and y. If I were to slide right 4 units and down 3, this would be my rule. So go ahead and try this example. It's about a square. It's pretty similar. You're just going to write down the new coordinates of the image, and then you're going to write down the rule using x and y and come back with that done in class the next day.